In this tutorial, I want to go through the example project, Jumping Balls. In the first tutorial, we looked at Jumping Ball, a simpler project. Jumping Ball has a single ball that moves around the screen, and it bounces off the sides of the arena. What I want to do now is migrate onto this more advanced example project called Jumping Balls, which is very similar but has multiple balls. And you might think that doesn't amount to much difference, but actually we're going to learn a lot about Gideros. We're going to learn three fundamental principles of Gideros. One is object-oriented programming, which Gideros supports and which is very useful in many games you might want to write. Another is to learn more about the event listeners that Gideros supports, and especially we'll be focusing on the enter-frame event listener. And we'll also talk a bit about Lua tables and how they can be used as a very flexible way to store data in different formats. So this is what we want to achieve at the end of the day. Let me start by going back to the basic jumping ball project. I'm just going to copy this code. Don't need to copy the comments. I'm going to start with this code rather than writing it out from scratch. So if you haven't looked through the first introductory tutorial, you should do that before you come to this tutorial, and the link is now on the screen. So let's start a new project. And we'll call it jumping_balls. I'm going to put it in a directory I have access to, namely Gideros examples. And I've asked Gideros to create a directory for my project, so it will create a new directory called Jumping Balls within Gideros examples, and within that new directory it will create a project file. Okay. Let's see what that got us. So I have created a new folder, hopefully, within examples called Jumping Balls, and it contains a gproj file which corresponds to an empty Gideros project. There are no source code files or assets here because I haven't done any work yet. I now want to copy some assets, so I'm going to go to the Gideros Start menu, Item, and access the examples. Within this, and within the graphics group, I can find the Jumping Balls project itself, and I'm going to copy the assets out of that project. Not the code, just the graphics. So let's just drag all these files across. And that, yes, the field is there as well. So all the files are present. I'll go to my project and I'll add existing files to the project, and I'm going to add all these graphics. 5 different types of balls and a background field. So these have all been successfully added to my project tree, directory tree structure. Now I need to add some code. Add new file, and we'll call the file main. Main.lua is normally where our main program lives. Now I've got main.lua, I'm going to paste in the code I showed you earlier. So this is just the code for a single jumping ball, and it should still work, except if I will need to change the name of my bitmap to ball1, because I don't have any ball called just ball.ping. Aside from that, everything should work as it did before. So if I run Gideros player, so that project runs as before. We have a single ball bouncing on the screen. My next task is to try to get multiple balls bouncing on the screen. Let's stop this for a moment. In this case, I've instantiated one ball called ball. If I wanted to make more balls, well, I could go ahead and just make multiple balls like this. We could call the first ball ball 1 and the second ball ball 2. And I can add all the balls like that. Within each ball, I would have to add its direction and speed and repeat this process. And presumably, I would want to add another enter frame. I would have a single enter frame rather, but within that enter frame callback function called onEnterFrame, I'd have to copy and paste all this code and reproduce it for both the balls. Well, clearly this is not a very efficient way of doing things, and it would lead to a very verbose code in the end, because I'd have to have a lump like that, and then another lump, where I substitute ball 1 for ball 2, and I can't extrapolate this to an arbitrary number of balls. And clearly the way forward is to have some sort of data structure capable of storing more than one ball. Each ball is a bitmap and is created by the bitmap.new factory function. So what I'm going to do instead is create a table. Local balls. This table will store all of my balls. To begin with, I'm going to make it into an empty table, and this is the Lua syntax for creating an empty table. So balls is just an empty table. I don't need to say what's going to be in the table. I don't need to define the type of the table. Indeed, in Lua, you can have a table with multiple things in it. I could have initialized the table to begin with. If I wanted to fill it with numbers, I could have said this. 1, 2, 3. Now the table is of length 3. Its first element is 1. Its second is 2. And its third is 3. Or I could have some text and a boolean, and so on. So I can have a mixture of things within the table. So I'm just leaving the table empty. I'm now going to add the first ball into the table. And what I say is ball 1 equals exactly the same as it is already. Bitmap.new texture.new. And I'll use the ball 1 texture for this one. Now I can do the same thing again for ball 2. So I can get rid of these commands. And the same for all the other balls. Let me change that to the correct ping file. And you noticed in Lua that my balls table started off empty, but now it's got 2 things in it, and I just added them as I wanted. I didn't have to extend the table. I didn't have to initialize the table to be of length 2 to begin with. I can just add more and more items to the table. So this is pretty amazing compared to, for example, a C array, where it has a fixed size to begin with. And in C, if you want to add progressively to an array, and you don't know how many elements there are to begin with, you have to deal with enormously complicated structures like binary trees and linked lists and all sorts of crazy stuff. In Lua, you don't need to worry. You just have an extensible table you can add more and more things into. So you never really need to do any memory management or play with linked lists or anything like that. So it really is pretty amazing. Even in Python, you'd have to extend the table to make it accommodate the extra elements. In Java, it would simply crash with a readable exception. In C, if you try to write outside the array bounds, it would crash with an unreadable exception. Lua does the most useful thing of all. It actually does what you intended. And that generally is the case for Lua. Let me go on and add the rest of the balls to the table. It's worth mentioning at this stage, instead of starting with an empty table and then adding the balls like this by index number, I could have filled the entire table all at once by doing something like bitmap.new and then another bitmap.new. and so on. So I could have created all the balls on the fly within the table and have the right size of table. Personally, I prefer to have an empty table and then add stuff in, because this line will get too long when I start stringing it out with 5 balls. And of course, all what you need in here is the texture.new and the reference to the actual file. So it gets rather long, but you can do it however you like. You can set up part of the table when you initialize it, add more stuff later, or just start it off empty and then start to fill it up by element. Another thing about Lua is it generally starts counting at 1. So the Lua programmer, if he sees 3 sheep, he counts them 1, 2, 3. This is very rare in the programming world. Most programmers will see 3 sheep and count them 0, 1, 2. However, if you do wish to start on 0, you can do that just as easily. There's nothing to stop you starting from wherever you want, in fact, and you could start counting like that as well, and minus numbers. I'm going to leave it starting at 1. Okay, so I've now allocated my 5 balls. I can now go through all these balls. I no longer have this sort of stuff. What I'm going to do is I'm going to loop over the balls and set their parameters. Now these parameters are just variables I'm adding on the fly within each ball, and they will dictate where the ball is moving to next. So as it bounces off the sides, the x and y direction will change. The x speed and y speed are kind of constant for that given ball. I want to make a for loop for I equals 1, comma. Now I could write 5. Let me do that to begin with. Of course there are 5 entities in it. End. That's how I write a for loop in Lua. So each of the balls is going to have its direction and speed. But slightly cleverer is to say hash balls. The hash operator returns the number of elements in the table. And you can see in this case it's kind of good that I started numbering from 1, because it would go up from 1 to 5. If I did want to number from 0 to 4, I would have to do 0 to hash balls minus 1, which is a bit uglier. Let's leave it counting at 1, which is the sort of official Lua way, and several Lua standard libraries will depend on you starting to count at 1. But fundamentally, there's nothing in the Lua language that forces you to start at 1. Now, I don't want all the balls to go in the same direction and have exactly the same speed, so let's use a Lua mathematical method to set some random numbers. Instead of this number, let's say math.random 40, 100 over 20. This will return a random number between 40 and 100, uniformly distributed, and we'll divide it by 20, so it goes from 2 all the way up to 5. Remember, in Lua there are no integers, so we're not going to run into any bad integer arithmetic. So in Lua, if you say 1 over 2, it evaluates to 0.5. Never evaluates to 0, it's one of the classic failures you can get in C or Java. So I'm going to give random numbers to all these things, and they have the balls have different speeds. And I'm going to start them all off at 1, 1, and moving horizontally to the right, moving vertically down. The other thing I'll want to do is alright, throughout I should have called this balls, because the array is actually called balls, not ball. Alright, balls I, let's set its position to something random as well within the arena. The arena stretches from 0 to 320 in the x direction and 0 to 480 in the y direction, which is just how I've set it up, but you could easily change that. Let's use the method setX on balls I, namely math.random. So let's make it 0 to 270 as its initial position. And for the Y direction, let's make the ball's Y position go from 0 to 430. Now the balls should start off in spread out positions around the screen. I don't need this code anymore. And I must remember to add the balls to the stage as well, so why don't I put that inside the loop also. It's not ball I want to add to the stage, it's balls I. Now the balls will all be on the stage. And we've still got the background. Let's not fire this listener now, let's comment it out. Okay, I encountered a bug, let's have a look at what that does. What that means. Bad argument number one to add child. Sprite expected got nil. On line 31. Yep, that's a line of code I should have removed. I've actually added all the children to the stage up above. So what I've done is I've created a whole load of balls, 5 of them as bitmaps. I've added them all to the stage, and I've added some useful information to them which will dictate their movement later, and I've actually set their positions to random places. Let's try running that. There we go. Let's run it again. Let's run it again. Okay, I can see here I need to do a bit of tidying up. I've not referred to ball 4 or ball 5. Let's run it again. There you see all the 5 balls, different color balls, and they start in random places every time I run the code again. That's great. Okay, let's consider making the balls move. Well, we have this add event listener. We've added an event to the stage, which is an enter frame event. This means every time the screen is redrawn, we call the function onEnterFrame, which is this function. Because I've inherited this code from another project, it's just updating one ball, but I'm going to have to change that to loop over all the balls and update them all. So let's do that. I'm going to add a for loop for I equals 1 to the number of balls do. And now, wherever I see ball, I'm going to replace it with balls I. So I get the xy coordinate of ball number I. We get its, we increment its x position according to its speed and direction. It might be worth me doing a find and replace here. Let's do that. Replace ball with balls I. Oops. Replace. That should do it. So now you can see what this function does on onEnterFrame. We loop over all the balls, grab the ball's position, update it. If the x is less than 0, then we must make the ball bounce. If it's greater than 320 minus the ball's width, then we again make it bounce in the opposite direction, and so on. Once we've got the final position of the ball that we want, we set balls I to be that position. Okay, so let's see if the balls now move. All of them. Nope, I forgot to do something. I forgot to end my loop, which needs an end as well. So in Lua, all blocks end with the end statement, whether they're if statements or for statements, or the end of a function. There we go. So, there we go. So, this is doing just what I wanted, right? And there's nothing wrong with this way of writing code. I've got all my balls, I've stored them myself in an array. I've instantiated all the balls, I've added them all to the stage. And my event listener goes over all the balls and updates them all. And you can write code in this way. It's not object orientated, but it works very well. And for some types of games, it's the best way to write it. But there are some disadvantages to this. One is I have to do quite a lot of effort to instantiate a ball on the screen. I have to get its bitmap ready, I have to set its various bits and pieces, which means I, as the programmer, have to know a lot about what's going on in the ball's class. Well, it's not even a class at the moment. What's going on with the ball's data structure. So if I were to give this to someone else, they can't really reuse the ball as a kind of separate entity and not have to worry much about it. They have to set all these methods and fields within each ball table entry, and they have to set up a ball table. And they have to add the ball to the stage, and so on, and actually write their own interframe event as well. So really, this is not portable code at all. So to begin to overcome this problem, let's think about this command, add event listener. Now, the stage is just a sprite. It has no special properties, and each of the balls is also a sprite. So any sprite, we can use the add event listener command to add an event listener to it. Let's just convince ourselves that all sprites have the add event listener method available. So here's my sprite. Every single sprite. Now sprites inherit from event dispatcher, so they get the add event listener command from an event dispatcher. You needn't worry too much about event dispatcher when you're writing Gideros code. But suffice to say that each sprite does indeed have access to the add event listener method. So at the moment I just have one event listener running on the stage. When an event fires, when an event happens, it is broadcast only to the stage. Only the stage receives that event. It then calls on enter frame, because that's what I've told it must do when it gets an enter frame event. It's registered to understand that event. What I could do instead, and let me bring this up towards where the balls are, is I could add an event listener to all of the balls. So instead of adding the event listener to the stage, I add it to the balls. So each ball now has an enter frame event listener registered with it. So Gideros will go over all the balls and say, well, this ball is registered to process enter frame. I will call enter frame on this ball. Now, this is obviously not going to do what we want, because each ball is going to advance all the balls, and they're all going to run about 5 times faster than we wanted. So because on enter frame this function comes after the balls, we've got to actually put it before the add event listener command is executed, it seems. Yep, so they're going way too fast, right? That's not what we wanted. So what I want to do is to only advance one particular ball. But how do I know? This on enter frame event is called for each and every one of these balls, and it has no way of knowing which ball is currently being processed. The solution to this is that there's a version of add event listener which takes a third argument. And that third argument will just be the ball itself. When it does take the third argument, when the update function, the callback function, is called, what happens is it gets an extra parameter in front of the parameter it had before. So the very first parameter it gets is an extra parameter, and that parameter will just be a copy of what we called when we instantiated, when we ran this method add event listener. So the third parameter was balls I. So when the event is processed on ball number 1, what it means is on enter frame will be called and self will be equal to ball 1. So all I need to do now, I get rid of the loop. Get rid of that loop. And I go through and I'm going to replace balls I with self. Let's Do a find and replace to make it very quick. That's right. Okay. So now every 60th of a second, what's going to happen is that an enter frame event will be dispatched to each ball, but the ball in question will be passed through as the third parameter. When the onEnterFrame function is called, the very first argument will be that ball itself. So I can then access all the important information about the ball, and importantly, I can run methods on that ball. So self, set position, x, y. You don't have to use the word self, but it's very traditional in Lua. Let's see if that works. Yes. So the balls are now bouncing around correctly. But we still haven't really got to object orientation yet. So to make this program into an object-oriented program, I want to create a new Lua source code file. And within this file, I'm going to create a class called ball. So I'm going to call the file ball.lua. I'm going to move all of the stuff to do with creating the ball and moving it around into this file. To create a new class in Gideros, you do this. So what I'm saying is I'm creating a class called ball with a capital B, and it's going to inherit from a class called sprite. Within ball, which is a table, I can add new functions, and the particular function I want to add is function ball.init self. This is the constructor function for the class. And the word init is special within Gideros. You have to use this particular name to instantiate your ball object. So this will be called whenever the user instantiates a ball object. So within this, I'm going to copy the code that I need to instantiate each ball. I won't need the loop because I'm going to do one ball at a time. Let's copy that out of there. And as you can see, this init method, which is the constructor, has access to self, which is the object we're just constructing now. So to self, we can set its x direction field, we can set its y direction field, we can set the speed. Now notice that self is a sprite. Ball is inheriting from sprite, so the self, or the ball in this case, is a sprite, so it has all the features of a sprite. So I can use methods that already exist within Sprite, like set x to a random position, and I can set y to a random position. But so far the ball is just a sprite, it's not even a bitmap. So I need to give it some physical appearance, because if I don't do anything, it will just be invisible. Whereas the bitmap actually has an appearance in itself. It inherits from Sprite, but it has its own appearance. We are creating a new object, ball, which is a replacement for bitmap. It's not just a bitmap, it has other methods in it as well, and other features. So we need to actually create a bitmap and add it to this ball object. So let's use a local variable within the init method. We call that bitmap. Local bitmap equals bitmap.new texture.new. But which texture should we use? Well, when I instantiate the ball, I want to be able to specify which texture I should use. So I will have another argument called file, and this is the file name of the texture that I need. So that will be a string actually. So from a given file I will create a bitmap. Now I need to add this bitmap as a child of self. So now my object that I've created, it's a sprite which has a single child which is a bitmap. So we'll be able to see the ball now. The other thing I want to do is to set this ball moving. And because it's a sprite, I can add an event listener to it. And I can still continue to use my onEnterFrame function, which works perfectly well, just as it did before. Again, I will use the 3-argument version of addEventListener. And the object I want to add in the last parameter will be self. So when I initialize this ball, it's set up in such a way that when onEnterFrame is called, its first parameter will be the ball itself. And now this function works perfectly correctly. For the given ball, for the given object, it will access that object and all the various components, and it will set the position of that object. So this is absolutely fine, and this should be sufficient to instantiate a ball. So let's go back to the main program. So I can remove all of this stuff, which I've now duplicated elsewhere. I still have a table of balls, which is an array of balls, but now each ball is going to be a ball object. So instead of bitmap.new, I do ball.new. And the way I've set up my ball.new class, I just pass a raw string to it. And when it instantiates the ball, it will deal with that string, load a texture based on the string, which is the file name of the texture we need, and create the object that way. Let me do this real quick. 5. Okay, so this should instantiate all the balls, and as soon as each ball is instantiated, it will start moving all by itself. The reason it will start moving is because when I instantiate the ball, I immediately add an event listener to that ball. So every 60th of a second, each ball will be sent an EnterFrame event, and it knows what to do with that event. It calls the EnterFrame function, passing itself through as the first argument, so the ball will effectively update itself. And as the programmer, the user of this ball class, all I have to do is instantiate the ball and leave it to do its own thing. So let's see if that works. Okay, I come across an error. So within the file balls lure, line 48, it can't get the length of balls. So what I've probably done here is I simply left a stub of code over. Let's get rid of that. Okay, let's run that. So we have another error. So in ball.lure in line 13, so the thing I should add to the ball is self. Sorry, the thing I should add to the state. Okay, let me try and understand this. Self is my object that I'm trying to instantiate. I've just created a bitmap. Actually, this is a leftover piece of code as well. So here's what I mean to do. I've instantiated a bitmap. I add that bitmap to self. And self is my object that I'm creating. That should work. Let's have a go. Okay, well, it didn't crash, but I must remember to add the balls to the stage still. I could have done that directly in the constructor, and let's practice doing that. So no reason why I shouldn't say stage add child self. So as soon as each ball is created, it adds itself to the stage. And that works. However, this is probably not the standard way of doing things, because as the creator of the ball class, you don't know what the user will want to do with it. He might want to add it to another sprite, and then add that sprite to the stage. So it's probably better to not do that, and instead what I'll do is I'll add all the balls to the stage manually. Let's do that using a loop. For I equals 1, comma, hash balls, do. Stage, add child, balls, I. Now, as soon as the balls are on the stage, they move around all by themselves. So all I have to do as the user of the balls is just instantiate a new ball with an argument in each case. The balls will automatically set themselves up, and the only thing I do have to do is add them to the stage. That looks pretty good, but there's just a few things I can do to improve this. Firstly, as far as the onEnter frame is concerned, this is just like a global function at the moment. More traditionally, one would add it to the ball class. And I just do it like that. So my function is now within the ball table itself. So I'm looking at onEnter frame, and it doesn't clash with any global onEnter frame that I might have created. Now, that shouldn't make any difference to the running of the program. But yes, here I can't refer to onEnter frame, it won't be able to find that. I do instead self.onEnter frame. Because this ball is self, we've created this object, and it has various methods. One of the methods is onEnter frame. It's not a method you'll call externally from the main program, but it is a method that can be called from the constructor, or indirectly called from the constructor, because what the constructor does is it registers, using add event listener, it registers self.onEnter frame, and Gideros will call that every 60th of a second. So now you can see I'm starting to build up a load of methods within my object, which starts to look like object-oriented programming. Like I said, that should make no difference. Good. There's another slight improvement, which is optional. There's a bit of syntactic sugar in Lua. I can actually replace this with the following. So you see, if I remove the dot and replace it with a colon, it just has the effect of automatically substituting self in without me having to type it. And now the code looks a bit more like C++ or Java. And what you've got to remember about Lua is these functions like init and onEnter frame have no automatic access to the object that they're acting on, which is why you will see self appearing everywhere in all these methods. So you have to pass self through to both init and onEnter frame, but by using this colon operator, it's syntactic sugar, and all it means is that it's automatically replacing, well, probably internally, Lua expands the colon into that. It becomes a dot, and self is passed as the first argument. Personally, I prefer to just leave it like this, with the self there explicitly. But like I say, if you use the colon, it starts to look more like Java, and you might prefer that style of programming. And you may have been wondering, if I have a sprite and I do something like set position, why do I use this colon all the time instead of a dot? Lua has both dots and colons. Well, it's exactly the same syntactic sugar. Let's say I do 100, 200. Sprite.setPosition is just the same thing as sprite.setPosition sprite, 100, 200. Because the setPosition method has no special access to sprite, it needs to be told which sprite it ought to set the position of, although it's sort of within sprite. Now, of course, it would be incredibly tedious to do this all the time, so people always will use the colon when it comes to calling methods. When it comes to actually writing the methods, you can use the colon or not, as you prefer. I'm going to leave it out and use self. The other benefit of Having the dot rather than the colon is you can call your variable anything you like this, and then I would replace everything with this if I really wanted to do that. If I use the colon operator, I've got to call itself, because Lua is basically deciding for me to call this hidden parameter self. So when do you use the colon? Basically, whenever you execute a method on an object in Lua, you will use the colon. You notice when I created a bitmap, I didn't use a colon. I used bitmap.new, not colon new. That's because bitmap is really a class method. It's not being operated on an object, it's being operated on a class. There's no object involved, and I'm actually creating an object. When it comes to fields, you will always use the dot, like we used it for x direction. There's no colon when it comes to fields, like variables, numbers, strings, which are part of the object. So I hope that clears that up. The colon is obviously quite a unique feature of Lua, but really it amounts to object-oriented programming and calling methods. Okay. So let me make this at least consistent. So that is an object-oriented program. Well, let's have a bit more fun. Let's consider having a few more methods. The balls can move. As soon as they're instantiated, they move, but why don't we have a start and stop method? Let's have a start method. It just takes self. What I'm going to do for the start method is I'm just going to copy this add event listener business in. In fact, let's get rid of it from the constructor, so when I construct initialize the object, it doesn't start moving yet. But rather, it starts moving only when I call the start method on it. And while we're at it, let's have a stop method. The opposite of add event listener is remove event listener. And remove event listener. When you're removing an event, you should make sure it's exactly the same event. It's possible for sprites to have multiple events of the same sort. So if I were to do, like make a mistake, this would have no effect because there is no event listener which has this exact signature. So I must make sure all three arguments correspond to the event listener that I added. And then the event listener will be removed. Once it's removed, the balls are not receiving events and they will not update anymore. Okay. So back in the main program, if I do this now, the balls should not move on construction. But I can start the balls moving by telling them to move. Ball start. Now I'm using the colon operator as I mentioned. I'm going to use number 1. The rest are not allowed to move. Let's have it the idea that the balls are able to make each other move. So let's set a partner for each ball. Partner. This will take self as it always does, but I'm going to add another ball which will be called the partner. And what that does is when I add a partner to the ball, I do ball.partner equals partner. And the idea is that the ball has another ball it can sort of talk to. Having done that method, I'm now going to cause the partner to, whenever the ball bounces off the, say the right-hand side of the screen, let's make its partner self.partner. Let's start that partner. So I can access the partner and I can run the start command on that partner. So provided I've set up a partner for my ball, It knows which partner it is. That's just a sprite which it's saved away, or rather it's a ball that it's saved away. It then looks up its partner when it bounces and it says, okay, that's a ball. It has a start method. I'll call that method. So now the balls are kind of talking to each other. Okay, and let's say balls 1 set partner balls 2. So now ball number 1 has a partner, which is ball number 2. So initially the ball number 1 should start, and then when it bounces off the side of the screen, ball number 2 should start. Okay, so let's see if that works. Okay, we've encountered an error. Bool.lua line 30, attempt to index field partner a nil value. So here's line 30. So you can see what I've done. Some of the balls don't have partners, so I shouldn't call partner unless it's actually set. If a variable is unset in Lua, it always has the value nil. So I can say simply if self.partner, then. So only try to start the new ball, the other ball, if partner is actually a non-nil value. And nil will always fail an if test, so it will not attempt to start a partner that doesn't exist. That should be enough to make it run. Let's see. There you go. Let's try that again. As soon as the black ball hits the right-hand side, ball 1 starts to move. Okay, well that concludes this tutorial. So we've learned about object orientation, we've learned a bit about tables in Lua, and we've learned more about the event listeners and the end-to-frame event listener and the add event listener command. Thank you.